Welcome everyone in lecture number 27. In this video lecture, I will tell you about Fourier sine transform. It is also called infinite Fourier sine transform. So let's start. Let we are given a function fx which is defined on this interval minus infinity to plus infinity, and in each partial subinterval of this interval the function is piecewise continuous. So first condition is that it is defined on this interval. Second is it is piecewise continuous on each partial interval. And it is absolutely integrable. Absolutely integrable in this interval. Then infinite Fourier sine transform of the function fx is defined as fs of fx. It is the notation that means infinite Fourier sine transform, and it is denoted by fsp. Fourier sine transform of any function fx is denoted by fsp and defined as integral 0 to infinity fx sine of px dx. And if we take the inverse Fourier sine transform of fsp, then its inverse Fourier transform is defined as inverse Fourier sine transform is defined as fx is equal to fs inverse of fsp, and it is defined as 2 upon pi integral 0 to infinity fsp sine px dp. Only the change in the inversion formula is that we have, in place of fx we have fsp, and the integration is with respect to p, and the integral is multiplied by 2 upon pi. Similarly, we can define Fourier cosine transform or infinite Fourier cosine transform. I'll write similarly we can define Fourier cosine transform. It is also called infinite Fourier cosine transform, and notation of this is fc of fx. fc means infinite Fourier cosine transform, and it is denoted by fcp and defined as integral 0 to infinity fx cos px dx. And if we take the inverse Fourier cosine transform of this function, then we can obtain the function fx, which is defined as 2 upon pi integral 0 to infinity FCP cos px dp. So both formulas are similar and it is easy to remember them. So we can also define the change of scale property for Fourier cosine transform and Fourier sine transform, as well as infinite Fourier transform. Change of scale property. Property is that if we have Fourier's transform, Fourier transform of any function fx is fp, then Fourier transform of any function of ax is 1 upon a mod a f p upon a. And if we are given Fourier sine transform of any function fx, which is denoted by fsp, then we can find Fourier sine transform of function of ax, which is equal to 1 upon a fs p upon a. Similarly, change of scale property also holds for Fourier cosine transform. If we have Fourier cosine transform of any function fx, which is fcp, then Fourier cosine transform of any function of ax would be 1 upon a fc p upon a. We can also define the shifting property. Shifting property for Fourier transform. What is that property? The property is if Fourier transform of any function fx is equal to fp, then Fourier transform of any function of x minus a is defined as e raised power ipa fp. This is only for Fourier transform. So let's take one example. Find Fourier sine transform of the function e raised to the power minus ax whole divided by x, where a is greater than 0. So we know that Fourier sine transform of any function fx is defined as integral 0 to infinity f of x sine of px dx. Okay. So here we are given the function fx, which is equal to e raised to the power minus ax whole divided by x into sine px dx. यानी हमें यहाँ पर साइन ट्रांसफॉर्म फाइंड आउट करना है इस फंक्शन का। ओके, तो इसको हम, इस पूरे इंटीग्रल को हम आई मान लेते हैं। अब इसमें हम एक ट्रिक ये यूज करेंगे कि अगर ये x कैंसिल हो जाता है किसी तरह, तो हम इसमें इंटीग्रल ऑफ e रेज टू द पावर ax साइन bx और cos bx dx का फॉर्मूला यूज कर सकते हैं। प्रॉब्लम क्रिएट हो रही है इस x की वजह से, तो इसमें लॉजिक ये है कि हम इसको इंटीग्रेट करेंगे, सॉरी डिफरेंशिएट करेंगे विद रिस्पेक्ट टू p. So x will be constant, that will come here, and this x will cancel with this x. This is the trick in this question. So we'll obtain di by dp, which is equal to x e raised to the power minus ax cos of px. Sin px की जगह हमें cos px मिल रहा है, that is no problem. For this we can use the formula of e raised power ax cos bx. So this is now equal to e raised to the power minus ax cos of px dx. By using the formula, we have e raised to the power minus ax whole divided by a square plus p square. ये आपको फॉर्मूला याद होगा, इंटीग्रल e रेज पावर ax cos bx dx का फॉर्मूला क्या होता है, e रेज पावर ax ओवर a स्क्वायर प्लस b स्क्वायर, फिर a cos bx प्लस b sin bx, ये होता है। इस फॉर्मूले से हम इसे ओपन कर रहे हैं, माइनस a cos px plus p sin px, and this is also inside this limit. So an upper limit for this whole quantity is 0 when you take the limit of this expression. Limit of e raised to the minus ax x tends to infinity is equal to 0. That makes the whole term equal to 0. And at lower limit we have this equal to 1, and here we have a square plus p square 1 upon, and this is because of this negative sign, and we have negative sign for lower limit, so we have a upon a square plus p square. So this is the value of di by dp. Now di will be equal to a upon a square plus p square into dp. When you integrate this, integrating this, we get I is equal to tan inverse p upon a plus c. Now if I put p is equal to 0, I use this condition. When I put p is equal to 0, you put this condition, we put the condition of p is equal to 0 here. If we put p is equal to 0, then I will be 0. So this is the condition that we'll use to find the value of c. I should mention from equation number 1. This implies when you put the p is equal to 0, I is equal to 0, so the value of c is also 0. This implies I is equal to tan inverse p upon a. This implies the value of integral 0 to infinity e raised power minus ax whole divided by x sine px dx, its value is tan inverse p upon a. Okay. Second example is find the value of fs x upon 1 plus x square. अब इसका मीनिंग क्या है? इनफाइनाइट फोरियर साइन ट्रांसफॉर्म फाइंड करना है आपको उस फंक्शन का. तो infinite Fourier sine transform of any function fx is defined as 0 to infinity fx into sine of px dx. इसको हम फिर से आई मान लेते हैं. अब हम इस क्वेश्चन में x से हम न्यूमरेटर और डिनोमिनेटर में मल्टीप्लाई करेंगे सबसे पहले, उसके बाद हम +1 और -1 करेंगे. तो I इज इक्वल टू हमें क्या मिलेगा? 0 टू इंफिनिटी x स्क्वायर अपॉन x इंटू एक्स स्क्वायर प्लस 1 sine of px dx. Now add 1 and subtract 1 so that you will have sine of px. We combine these है ना, तो x x ये कैंसिल हो जाएगा, 1 अपॉन x बचेगा, साइन पी एक्स अपॉन एक्स हो जाएगा. And in second integral we have sine px whole divided by x into x square plus 1. इसकी वैल्यू हमने लाप्लास ट्रांसफॉर्म में फाइंड करी हुई है. ये वैल्यू, उसकी वैल्यू होती है π/2. ओके, लाप्लास ट्रांसफॉर्म से आएगा ये, लाप्लास ट्रांसफॉर्म इंटीग्रल्स प्रॉपर्टी से. एंड this integration is written as it is. Now what we do here is, at this stage, we differentiate this with respect to p. So we get di by dp is equal to 0 minus cos px, and one of the x will cancel with this x, into x square plus 1. Mark this as equation number 3 and this has equation number 2. Now we differentiate it again because I want this expression, or you will have the, when you have differentiate, you will have x sine px dx type of expression. Differentiating again, we get d2i over dp square is equal to integration sine px multiplied by x over x square plus 1, and this is nothing but I. इसको ही आपने I माना था, है ना? तो we can replace it by I. तो आपके पास डिफरेंशियल इक्वेशन बन गई d2i over dp स्क्वायर माइनस I इज इक्वल टू 0. अगर हम d over dp के लिए सिंबल यूज करें कैपिटल D, तो हमारे पास इक्वेशन है d स्क्वायर माइनस 1 इंटू I इज इक्वल टू 0. इस टाइप की इक्वेशन को कैसे सॉल्व करेंगे? हम ऑक्सिलरी इक्वेशन निकालेंगे. ऑक्सिलरी इक्वेशन आएगी एम स्क्वायर माइनस 1 और इसके रूट्स आएंगे m इज इक्वल टू प्लस माइनस 1. तो कोफिशिएंट कॉम्प्लीमेंट्री फंक्शन क्या हो जाएगा? c1, दैट इज आप c1 की जगह a भी ले सकते हो, a इंटू ई टू द पावर p, क्योंकि डिफरेंशिएशन विद रिस्पेक्ट टू p है, एंड प्लस b इंटू ई रेज पावर माइनस p. इंटीग्रेटिंग फैक्टर 0 होगा. सो particular integral will be 0 because right hand side is equal to 0. So we have complete solution. I is equal to a e to the power p plus b e to the power minus p. अब हमें कांस्टेंट की वैल्यू इवैल्यूएट करनी है. तो अब आप यहाँ पर आइए इक्वेशन नंबर 2 पर. अगर यहाँ पर हम p को 0 सब्स्टिट्यूट कर दें तो i की वैल्यू पाई बाय 2 हो जाएगी. तो एक कंडीशन तो हमें ये मिल गई दैट from equation number 2 at p is equal to 0, I is equal to pi by 2. सेकेंड इक्वेशन नंबर 3 में आइए. अब यहाँ पर आप जब p 0 रखेंगे तो di by dp की वैल्यू कितनी आएगी? जब आप p 0 रखोगे तो ये हो जाएगा 1 अपॉन एक्स स्क्वायर प्लस 1. उसका इंटीग्रेशन tan इनवर्स x आएगा. tan इनवर्स x इंफिनिटी पर पाई बाय 2 होता है. बिकॉज ऑफ दिस नेगेटिव साइन वी हैव माइनस पाई बाय 2. ओके, so I'm not showing the solution. So from equation 3, we have at p is equal to 0, I di by dp is माइनस पाई बाय 2. तो ये दो कंडीशन हमें चाहिए बिकॉज वी हैव टू कांस्टेंट वैल्यूज. तो हम ये दोनों कांस्टेंट पर ये कंडीशन अप्लाई करेंगे. इक्वेशन नंबर 4, अप्लाइंग these two conditions on equation number 4. तो पाई बाय 2 जब आप रखोगे, सॉरी आई पी 0 रखोगे तो आई पाई बाय 2 है. p 0 पर यू हैव a प्लस b इज इक्वल टू पाई बाय 2, and di by dp, so we have to find di by dp, which is a into e raised power p minus b into e raised power minus p. So it will be a minus b is equal to minus pi by 2. Now we add them so that we have a is equal to 0 and b is equal to pi by 2. So we have the value of I is pi by 2 e raised to the power minus p, and this is the answer. आपको I ही evaluate करना था क्योंकि आपने इसको I माना था, इसलिए I की वैल्यू हमें फाइंड आउट करनी थी. दैट इज pi by 2 raised to power minus p. That's all. I'll discuss more problems on Fourier sine and cosine transform in my next lecture. I hope you understand it, and if you have any doubt you can ask me. Okay, and if you like my lecture, please press the like button, share it, and subscribe my channel if you have not subscribed it yet. Thank you so much for watching the video.